Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, how are you today? Today we will learn about derivatives of parametric function. Times in we express the variable x and y function of a third variable t by a pair of function. In here, x equal ft and y equal gt. Function like this are called parametric function and the variable t is called the parameter. So guys, if we just have two variable, it's called by implicit function. But if we have third variable, it's called parametric function. Okay, do you understand? Okay. Parametric differentiation is it still look like with the implicit if the implicit dy over dx, but in here in parametric differentiation dy over dx is equal, right? Yeah, but they have equal with dy over the third variable like here, because in variable y have a t, so dy over dt, and then x have a variable of t, so dx over dt. Because we can cancel dt each other from numerator and denominator, so it's still the same result with dy over dx, where di over dx is not equal 0. This enables us to find the derivative of parametric function without having to eliminate the parameter t. So if in here, if they just have two variable, it's still implicit function. Remember, if they just have two variable, it's still called implicit function. If they have third, it's called parametric function. If they have one variable, it's called explicit function. You should remember about three of these things. Okay, example. Find the derivative with respect to x of the parametrics x equal t plus 2 and y equal to t square minus 1. So the solution we see here is x equal t plus 2. So we should derivative x to be t and then y to be t. So x equal t plus 2 have derivative. Because t is just 1, we just derivative x over t, so it's 1. And then derivative of t from y is 4t. Okay? Remember, please derivative with the what of the variable. Because they ask about the first derivative, so because the first derivative is equal dy over dx, so you can rewrite dy over dx equal, because in here is y, so you just need to put dy over dt and then dx over dt, because we can cancel dt and dt to be dy over dx. Okay everyone, do you understand? So you just need to substitute dy over dt is equal 40 and then dx over dt equal 1, so 40 over 1 is 40. Okay, example. If a is a positive constant, x equal a cos t cosine t and y equal a sine t, find the dy over dx. So the solution, you should derivative x to be t. Okay, so x equal a cosine t and y equal a sine t. So dx over dt equal derivative of cos is minus sin, so to be minus a sin sine t, and then because y derivative to be t, so dy over dt equal derivative of sin is cos, so a cosine t. So dy over dx is equal dy over dt over dx over dt. So you can cancel dt and dt. So the result is the same with dy over dx. So you can cancel a from here. Cosine over sinus is to be cotangent t. So the result will be minus cotangent t. Example. The parametric curve is given by the equation x equals square root of t plus 1 and y equal t square plus 3t. Find the slope of tangent if x equal to. So you need, first thing first, you should derivative of this x and derivative of this y to be a dt. So derivative of dy over dt is 2t plus 3, and then derivative of dx over dt is equal half times t plus 1 power minus 1. Why minus 1? Because half minus 1 is minus half times function. This function half derivative is 1. So dy over dx equal dy over dt over dx over dt. So you can cancel dt, is still the same result with dy over dt. So equal, you substitute the dy over dt to be here and the x over dt to be here. So the result for the first derivative is 2 times 2 3 plus 3 times t plus 1 power half. So we need to find the slope of tangent because here is half x equal to, so you need substitute x equal to be, so you need substitute x equal to be here, to be this function. So x squared minus 1 equal t, because x is 2, so 4 minus 1 is 3. So we get t equal 3. So we already know a slope is equal with the first derivative. So the first derivative is 2 times 2t plus 3 times t plus 1 power half. So you need to substitute from here to be here. So the result will be until m equal 36. Do you understand, everyone? So because they just ask find the slope, so you can answer until this one. But if they have asked about another like tangent line or something like that, you should finish it first. Okay. Next example. Okay. The parametric equation x equal 1 plus exponent power t minus 1 and y equal t squared plus ln t describe a curve in the plane. Find the tangent line to the curve at t equal 1. Solution. You need to derivative because x have the variable of t, so you need to derivative is dx over dt. Derivative 1 is 0, so we don't need to put in here. So derivative of exponent power t minus 1 is their self times the derivative of this function, because this function is t minus 1, so derivative of t is 1, and then derivative of y, because in here it is t, so derivative dy over dt is equal to t plus 1 over t, because derivative of ln is 1 over t. So you can have same numerator, same denominator, so the result will be like 2t squared plus 1 over t. So like the previous one, dy over dx is equal dy over dt over dx over dt. So you can cancel dt each other, and then you just need to put substitute the dy over dt to be here, and then dx over dt to be here. So make the simplifying like this one. Okay. They ask about find the tangent line to the curve at t equal 1. So what you need to find first, you can find the slope. First thing first, you can find the slope, because the derivative of the previous is 2t squared plus 1 over t times exponent power t minus 1. So you need to substitute this t to be here. So the slope is 3. Okay. We got the slope of 3, and then we need to find the score of x. So we need to substitute t to be here. 1 plus exponent t minus 1. So substitute t equal 1 to be here. Exponent power 0 is 1. So 1 plus 1 equal 2. So then we find the y. Y is equal t squared plus ln t. We need to substitute t equal 1 to be here. 1 power 2 plus ln 1. Ln 1 is 0. 1 plus 0 is 1. So we get the point a curve is 2.1 and tangent and the slope is equal 3. So because they ask about tangent line, the formula of tangent line is y minus y equal m times x minus x. So you need to substitute to be here, and then the tangent line is y equal 3x minus 5. Okay, everyone, I hope you understand until this one. If you don't understand, you can ask me in the comment below, okay? Okay, another differentiation. So this one is about parametric differentiation of second order. So that the meaning you have differentiate that function two times because they ask about second order. Look here, d square over y over dx power square is equal dy square. No, pardon, sorry. Dy prime equal dx because this one is the half parametric, have the variable t. So dy prime over dt and dx over dt. One, express y prime equal dy over dx in terms of t. So you need to derivative of dy over dt and dx over dt. Differentiate y prime with respect to t and divide the result by dx over dt. Okay, let's example to make it easier for you guys. A parametric curve is given by the equation x equal 1 plus exponent power t and then y equal t square exponent power t. Find the second derivative d square y over dx square. So you need make this one to be first derivative. So dx over dt because derivative of 1 is 0. Derivative of exponent power t is their self. And then derivative of y, dy over dt, they are using the product rule. So derivative of t square is 2t times v times plus u t square times derivative of exponent power t is their self. So the first derivative is dy over dx equal dy over dt over dx over dt. Okay, you just need substitute here to be here and then exponent power t to be here. Okay, because numerator have the same denominator, you can cancel each other, so the result will be 2t plus t square. Okay, everyone, do you understand until the first derivative? Now we continue to the second derivative. dy prime equal dt. Example, y prime is equal dy over dx. So you need change y prime to be dy over dx. So the result will be like this. So d over dt, y prime is changed to be dy over dx to be here. Okay, so derivative of dt. So function dt, this function of f prime, this one substitute here. So derivative of dt, so 2 times 2t. So the second derivative of x equal dy prime over dt over dx over dt equal 2 plus 2t x over exponent power t. So do you understand, everyone? Okay, you can answer like this question step by step. Be patient, be intelligent, be with your truly heart. You want to answer this question because this one is you must be diligent. It's like 100 more than 100%. You must be diligent in here. Maybe you will confuse about how to using y dy, y dyx, and y dt, y d square y dx square, but it's okay. Life is learned. So you learn step by step until you understand by yourself. Okay? Example. Find the second derivative if x equal to t minus t squared and y equal 1 minus t cubed. So you need to find the first derivative about dx over dt and then dy over dt. So dx over dt is 2 minus 2t and dy over dt is minus 3t squared. And then for the first derivative, dy over dx is dy over dt over dx over dt. So you need to substitute dy over dt is minus 3t power 2 over 2 minus 2t. After that, you need to find the second derivative of y. So dy square over dt is equal d over dt. Y prime is you can change to be dy over dx. So you need to change y prime to be dy over dx because the first derivative is dy over dx is minus 3 to minus 3 times t square over 2 minus 2t. So you need to substitute this one to be here. So d over dt, derivative of this function to be t is like this one. But you need to using let 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 numerator to be u equal minus 3 to 2. So the prime of u is equal minus 60. And then the phi is 2 minus 2t. So derivative is minus 2. Because this one is the equation rule, u prime is minus 60 times phi. Phi is 2 minus 2t minus u is minus 3 to power 2 times p prime is minus 2. So the result, this one to be like this. Okay, everyone? Okay, like I said before, be patient. Okay, the second derivative of this formula is you need to substitute here to be here over 2 minus 2t. Okay, the result is 6t power 2 minus 12t over 2 minus 2t power cube. So if you want to make it very simple, it's okay. But until like this is okay too. But like I said before, be careful, be patient, be diligent to answer the second derivative of parametric function. Another example. Find the second derivative of a parametric curve given by x equal 1 plus exponent power t and y equal 1 minus sinus t. Derivative of dx over dt is exponent power t and derivative of dy over dt, derivative of sine is cos. So minus cos t. So dy over dx is minus cosine t over exponent power t. So we need to find the second derivative. dy prime over dt is equal d over dt have a prime of the function. So you need to substitute here to be here. So let minus cos t to be u. So derivative of minus cos t is sinus t. Derivative of exponent power t is exponent power t. Because this one is equation rule. So up prime minus u prime p minus up prime over p square. Because in here they have the same in numerator and denominator they have same exponent power t. You can cancel each other. So the result will be like sinus t plus cosine t over exponent power t. So the second derivative of this function is substitute here to be here over exponent power t. So the result sin t plus cosine t over exponent power 2t. I hope you understand. Okay, like I said before, please be patient. Like be diligent, be intelligent to answer, and then be honest. You should have doing with your heart. Okay, everyone is what I am saying. Okay. So thank you for today. If you want have more confident to answer parametric function, please do exercise on check yourself 18, page 66 on Zambak's book. I hope you enjoy this lesson. I know mathematics is easy as long as you're doing with your heart, and then be patient, be diligent. I hope you like what my video today. So see you next time. If you like this video, please give thumbs up, share, and subscribe. If you want, please give a comment in my YouTube channel. What your suggestion for me? And then thank you for today. Assalamualaikum warahmatullahi wabarakatuh.